Hello everyone, this is Fuji Research. This picture shows a cut of a tire. Most component of a tire is rubber, but do you think rubber can be firmly sustain shape of a tire? Especially a tire used for trucks receives heavy load. There should be reinforcement inside the tire, that is tire cord. Aramid is used for it also. First, I want to check a drive belt used for a vehicle. Bando Chemical is one of its manufacturers. An example of a high-strength type, aramid fiber is used as its cord. A drive belt must have anti-stretch feature. Teijin supplies aramid coating for separator of lithium-ion batteries. Toray also develops aramid film for separator of lithium-ion batteries. Toray's aramid film, launched on market as Mictron, is used for electronic components. It has brilliant heat resistance next to polyamide. So what is aramid? Let's check it out. Aramid is also called aromatic polyamide. This is aromatic compound having amide bond. An aromatic compound is a chemical normally containing at least one benzene ring. To understand the molecular structure of aromatic polyamide, we had better to check that of popularly known polyamide, that is nylon. You see, at the center of polyamide monomer is called amide bond. You can also see two hydrocarbons at both sides. If those are replaced with benzene rings, it is going to be monomer of aramid. Let's see how to make aramid. It involves chemical reaction between terephthalic acid and paraphenylene diamine. Both chemicals have benzene rings. Aramid can be broken into two types. One is para-type aramid, and the other is meta-type aramid. As you can see, they are different in the location of bond to benzene ring. Now we shall look at some properties of aramid. First one is about the long-term heat resistance, meaning the polymer can keep its heat resistance property for a long period of time. Toray's aramid film is called Mictron, and it has excellent property next to polyamide. Next one is bend stiffness. Please check this chart. In this chart, benchmark is performance of 12.5 micrometer thick of polyamide film as a value of 1. Toray's Micron performs much better than PET and polyamide. For instance, 7.5 micrometer thick of Mictron demonstrates 3 times stiff that of PET film. Third, I like to look at the property of gas barrier. This chart tells ability to resist transmitting oxygen and water vapor through various films. It is obvious that the Mictron outperforms films of any other materials. Last one is with regard to surface smoothness. Thanks to Toray's technology of surface smoothing, Mictron's surface roughness achieves as low as 7 micrometers. These photos are for comparison with polyamide. By the way, speaking of history of aramid, a chemical company DuPont appears. It invented meta-type aramid in 1960s and started selling para-type one, called Kevlar, in 1973. Why don't we have a glance at the history of Toray? Origin of Toray is the maker of rayon named Toyo Rayon, established in 1926. Its first president was Yunosuke Yasukawa, who was from then Mitsui. In 1951, Toray had a technical partnership with DuPont and then started the production of nylon fiber. In 1980s, Toray had aramid and PPS launched on market. As usual, high-performance polymer comes out later. Well, where is Toray's aramid produced? A document shown in Toray's website said Mishima Plant in Shizuoka Prefecture produces film web of Aramid and PET. Mishima city of Shizuoka Prefecture is about 72 miles distant from center of Tokyo. There are Route 1 and Route 246 near the city. Also, it is about 13 miles away from a well-known sightseeing area that is Hakone. Let us zoom in. Toray Mishima Plant is walking distance from JR Mishima rail station. I am going there